In this particular question, we've been asked to find the general solution for f prime of x equals 6x squared plus 14x plus 5. What this means is that we've been given the differential equation, f prime of x, and we want to find f of x. So we have to use antiderivatives. Now I'm going to take out the green marker and I'm going to talk you through the steps that really should be done in your head. I'm just doing this for the first example. After this, I would expect that you should be able to do the following in your head. Well, f of x is going to equal, well, my first value of x is an x squared. So I've got to increase that exponent by 1, so now it'll be an x cubed. And then I take that value and I divide it into the existing coefficient, which is 6. So 6 divided by 3. And I continue that process with the next term. It used to be a 14x, where the x is solely to the 1. So now that exponent is going to be increased by 1, so it's now an x to the 2, or x squared. And I take that value, 2, and I divide it into my existing coefficient. So I have 14 divided by 2. The next term was a plus 5, which is really a plus 5 times x to the 0. So I increase that exponent by 1, so it's no longer an x to the 0, but an x to the 1. And I take that value 1 and I divide it into the existing coefficient, which was 5, so I have 5 divided by 1. And then I must put c, where c is an element of real numbers, meaning there is an infinite number of possibilities for c, or the y-intercept of our particular function. So when I simplify that, f of x is equal to 2x cubed plus 7x squared plus 5x plus c, where c is an element of real numbers. In the next question, we've been asked to find the general solution given that k prime of x is equal to 3x plus 2 all in brackets squared. Now, we haven't learned some of the more complicated rules for doing anti-differentiation. So what we're going to be forced to do is first expand this particular binomial before we can use the limited rules that we've learned for anti-differentiation. So k prime of x is going to be equal to 9x squared plus 12x plus 4. So if I take the antiderivative of this to find k of x, first thing I would do with that x squared is increase its exponent by 1, so it's now an x cubed, and take that 3, that's the exponent, and divide it into the coefficient 9, and I get my new coefficient 3. Go over to my next term, which is a 12x. I'm going to take that x to the 1, I'm going to increase its exponent by 1, so it's now an x squared, and I take that value 2, and I divide it into the coefficient 12, so that I get my new coefficient 6. When I take the antiderivative of 4, I get 4x, and then I put plus c, where c is an element of real numbers. So if you're not sure if you've done the anti-differentiation correctly, remember that all you have to do is take the derivative of k of x, and if you get k prime of x, you know you've done the question correctly.